You have memories, a childhood, a first kiss maybe, a terrible haircut from middle school. You remember breakfast this morning, or at least you think you do. But here's a question that should terrify you right now. How do you know any of that actually happened? What if you blinked into existence 1 second ago, fully formed, complete with false memories of a life you never lived? A brain floating in the void, convinced it has a history, convinced it has a body, convinced it is listening to a podcast? That sounds absurd, like something you would laugh off. But the math is not laughing. According to the statistical mechanics Boltzmann pioneered, applied to modern cosmological models, this scenario is not just possible. Under certain widely accepted frameworks, it is statistically more likely than the alternative. The math suggests you are probably not real. At least, not in the way you think you are. Welcome to the Boltzmann Brain problem, the most unsettling result in the history of physics. And here's what will keep you up tonight. The deeper you go into this argument, the harder it becomes to find the flaw. Let me show you why. If you want more physics that breaks your brain, hit subscribe. Right now, somewhere in the equations that govern our universe, there's a calculation that says your memories are fake. Not metaphorically, not philosophically. The actual math of thermodynamics and cosmology produces this result. Ludwig Boltzmann was a 19th century physicist who helped build the foundation of statistical mechanics. He gave us the statistical interpretation of entropy, showed how disorder increases, and revealed how the universe winds down. But his framework had a disturbing implication that no one fully reckoned with during his lifetime. If you wait long enough, and in an eternal universe you have forever, random fluctuations will occasionally produce ordered structures. A molecule here, a rock there, and given infinite time, a brain. A conscious brain complete with false memories, floating alone in the void. The math says these phantom observers should vastly outnumber real ones. Real observers like you, observers who evolved on planets, who grew up, who had that terrible middle school haircut. Which means, if the math is right, you are probably one of them. If you want to understand why physicists take this seriously, subscribe and keep listening. The math that proved atoms are real also suggests you might not be. That is the paradox you're about to confront. Ludwig Boltzmann was born in Vienna in 1844. He was brilliant, troubled, and ahead of his time. He essentially co-founded statistical mechanics, the bridge between the atomic world and the everyday world of heat and temperature. In Boltzmann's day, many scientists did not even believe atoms existed. They were considered a useful fiction. Boltzmann helped prove otherwise. He showed mathematically that gas behavior, pressure, temperature, all of it, could be explained by the random motions of countless tiny particles. His key insight was connecting entropy to probability. That equation carved on his tombstone, that's equals K log W, says that entropy is just a measure of how many ways a system can be arranged microscopically while looking the same macroscopically. But Boltzmann was attacked relentlessly. Scientists like Ernst Mach and Wilhelm Ostwald thought atoms were speculation, not science. The philosophical movement of the time rejected invisible entities. The criticism broke him. In 1906, while on vacation in Duino, Italy, Ludwig Boltzmann took his own life. The tide was beginning to turn in his favor. Einstein's 1905 paper on Brownian motion had already laid the theoretical groundwork that would soon enable experimental proof of atoms. But full vindication came too late. Here's the tragic irony. Boltzmann's equations were so powerful that they led to a conclusion even he might have found disturbing. A conclusion about brains appearing from nothing in the void. The very math that validated atomic theory also suggests you might not be real. If you want to see why, hit subscribe. Here is the concept that threatens your entire sense of reality. entropy. And yes, your memories need to be real to follow this, which is exactly what we are about to question. Entropy is often described as disorder, but that is not quite right. It is really about probability. High entropy states are probable. Low entropy states are improbable. Think about a deck of cards. A shuffled deck, cards in random order, is high entropy. There are roughly 8 times 10 to the 67th possible arrangements. That is more than the number of atoms in the observable universe. But a perfectly ordered deck, ace through king, all 4 suits in order, that is incredibly low entropy. There's basically one way to do that. If you shuffle a deck, you will essentially never get a perfectly ordered result. Not because it is impossible. It is just overwhelmingly improbable. Now scale that up to the universe. A universe full of stars, planets, and people is low entropy. It is ordered. It is structured. Like that perfectly sorted deck. But here is Boltzmann's insight. Given enough time, random fluctuations in a high entropy void will occasionally, accidentally, produce low entropy structures. Molecules bumping around will sometimes, by pure chance, arrange themselves into something interesting. Now here's the part that should unsettle you. What's more likely? A random fluctuation that produces an entire ordered universe with billions of galaxies, trillions of stars, and at least one planet with life? Or a random fluctuation that produces just a brain, a single conscious entity with false memories of that universe? The brain is vastly more likely. It is a smaller fluctuation, less improbable. So if you're betting on what kind of conscious entity you are, one that evolved in a real universe or one that flickered into existence moments ago, the math says you should bet on the fluctuation. Most physicists treat this as a sign something is wrong with the theory, not a literal prediction. But the logic, once you see it, is hard to escape. If this is making you rethink everything, subscribe for more. Here is why this keeps physicists awake at night. Mainstream physics might be broken, not in some abstract academic sense, in a way that undermines the foundation of how we do science. Boltzmann Brains are a way of testing whether a theory has gone off the rails. If your cosmological model predicts that Boltzmann Brains should vastly outnumber real observers, then your model has a problem, because you cannot do science from inside a Boltzmann brain. Your memories are fake. Your observations are illusions. Your entire experience is a random fluctuation that will dissolve back into chaos in a fraction of a second. Sean Carroll, the physicist, puts it bluntly, we are not arguing that Boltzmann brains exist. We are trying to avoid them. Think of it like a sanity check in software. You know when you write a function and you add a check that should never fire? Like, if user count is less than 0, throw something is very wrong. Boltzmann brains are that check for cosmological theories. If your theory predicts infinite Boltzmann brains, your theory fails the sanity check. Something in your assumptions is broken. And here's what makes this more than academic. Several mainstream cosmological models do predict infinite Boltzmann brains, including some versions of eternal inflation and certain interpretations of dark energy. Which means either those theories are wrong, or we need to find a way to escape the Boltzmann brain conclusion. And right now, nobody has a clean answer. You're about to discover that the most unsettling implication of dark energy is not that the universe is expanding. It is that the expansion might guarantee you are not real. In 1998, 2 teams of astronomers discovered that the universe's expansion is accelerating. Something is pushing space apart, and it is getting faster over time. We call this dark energy, and we still do not really know what it is. The simplest explanation is Einstein's cosmological constant, a fixed amount of energy inherent in empty space itself. But here's what that means for you. If dark energy is a cosmological constant, and the universe keeps expanding forever, then we end up with something called de Sitter space. A vast, cold, empty universe that lasts for eternity. An eternity is a long time. In an eternal universe with constant vacuum energy, there are always random quantum fluctuations happening. Given infinite time, every possible configuration of matter will eventually occur, including Boltzmann brains. Infinitely many of them. This is the Boltzmann brain problem for modern cosmology. Our best model of dark energy seems to predict that the universe will produce an infinite number of illusory observers, vastly outnumbering real ones like you. Some physicists argue that dark energy might not be constant. If it is something called quintessence, a dynamic field that could eventually dissipate, then the accelerating expansion phase might end. Problem avoided. Others suggest that vacuum decay might save us. The universe could be in a false vacuum that eventually tunnels to a lower energy state, destroying everything, including any potential Boltzmann brains, before they can outnumber us. In other words, one solution to "you might not be real" is, do not worry, everything will be destroyed first. Your best hope for being real? The universe ends before the math catches up. Comforting. If you want to know what engineers see in this paradox, subscribe and keep going. You have spent your whole life trusting your own observations, every measurement, every memory, every sensory input. Now imagine a system where most of the observers are lying, and they do not even know it. That is exactly what the Boltzmann brain problem describes. In distributed systems, we deal with something called Byzantine faults, named after the Byzantine generals problem. How do you coordinate when some of your nodes might be lying or malfunctioning? A Byzantine node might send different messages to different parts of the system. It might claim to have data it does not have. It might have corrupted memory and not even know it is lying. A Boltzmann brain is the ultimate Byzantine node. It is a conscious entity with corrupted memory, making claims about observations it never actually made in a universe that does not exist the way it thinks it does. And here's the critical parallel. In distributed systems, we can handle a few Byzantine faults. We have consensus algorithms, ways for the honest nodes to outvote the liars. But if most of your nodes are Byzantine, you are screwed. The whole system's sense of reality falls apart. The Boltzmann brain problem is asking, what if most of the observers in the universe are Byzantine? What if the honest observers, those of us who actually evolved in a real universe, are outnumbered by random fluctuations that only think they are making valid observations? How do you achieve consensus on reality when most voters are hallucinations? If this crossover between physics and computer science hooked you, subscribe for more. Physicists used to treat Boltzmann brains as a terrifying open question, but recent research is reframing them as something different, a sign that our math is broken, not our reality. In July 2024, physicists Carlo Rovelli and David Wolpert published a paper arguing we should not worry about the standard Boltzmann brain argument. Their key insight: the argument assumes we can meaningfully assign probabilities to our own existence in infinite ensembles, meaning infinite collections of possible observers, and that assumption might be flawed. Also in 2024, Associate Professor Brian Woodcock at Rutgers placed the Boltzmann brain theorem alongside other infinity paradoxes, like the St. Petersburg paradox and Zeno's paradox. His argument: when you use infinite resources in probability calculations, you often get results that do not match finite reality. Boltzmann brains might be a symptom of misapplying infinity, not a genuine prediction about you. In early 2025, a paper in the journal Philosophia titled "Infinite Time and the Boltzmann Brain Hypothesis" tackled this from a philosophical angle. The authors argue that our standard understanding of the second law of thermodynamics combined with the assumption that the future is infinite, technically entails that you are most likely a momentary Boltzmann brain. But, and this is crucial, they suggest this reveals a problem with how we reason about infinite futures, not a fact about your existence. Meanwhile, a 2025 paper in analytic philosophy proposed what the authors call a shielding strategy, using a form of phenomenal externalism, the idea that consciousness depends on external relationships and causal history, not just internal brain states. They argue that even if Boltzmann brains outnumber us, their proliferation is benign. A brain that flickered into existence with no causal history might not be conscious the way you are. Here's the shift that matters to you. Physicists are increasingly treating Boltzmann brains not as a genuine existential threat, but as a diagnostic tool. When a theory predicts infinite Boltzmann brains, that prediction is a red flag about the theory, not about your reality. The terrifying question is becoming a useful one. And useful questions are the ones that actually move physics forward. Discover what the Boltzmann brain debate means for your own existence right now. Are you a Boltzmann brain? A fleeting phantom with false memories about to dissolve back into the void in a fraction of a second? Almost certainly not. And that is not just wishful thinking. The fact that you are following a coherent argument across time, that your memories connect to a consistent world, that the physics you observe follows predictable laws. These are all evidence against the Boltzmann brain hypothesis. A true Boltzmann brain would dissolve back into chaos almost instantly. Its false memories would not connect to anything real. The very fact that you are still here, still listening, still existing moment after moment, that is actually evidence that you're not a random fluctuation. But here's what makes this whole mess beautiful. The Boltzmann brain problem forces us to confront what it means for a cosmological theory to be true. A theory that predicts you probably do not exist the way you think you do. That theory has a bug. It is like a compiler that always produces code claiming the compiler does not exist. Technically consistent, but deeply suspicious. We use Boltzmann brains the way we use unit tests. Not because we expect them to pass, but because when they fail, we learn something. A theory that generates infinite Boltzmann brains is telling us something is wrong with the theory, not with reality. And maybe that is the real takeaway. The universe might be strange, might be vast, might be indifferent. But the math that predicts your non-existence also predicts its own unreliability. Your memories are probably real. Your breakfast this morning probably happened. The math that says otherwise, that math might be the real illusion. If this made you think, subscribe so you do not miss what comes next. Can a machine truly understand language? Or is it the most sophisticated symbol shuffler ever built? Next episode, you are diving into the Chinese room argument, John Searle's famous thought experiment that draws a sharp line between processing and understanding. What that line means for ChatGPT and every AI after it will challenge everything you think you know about intelligence. This is Chris, logging off from somewhere deep in the stack. Probably real, statistically speaking. Like and subscribe, assuming you exist, to click the button.